consider the function f of x, which is 2 over pi multiplied by sine of 3 pi x plus 2. Question A, write down the amplitude of f and find the period of f. The amplitude is just this coefficient in front of sine. Why? Because just sine or cosine, it changes from -1 to 1, and this distance from the principal axis to the maximum or to the minimum, it's called the amplitude. So for just sine or cosine, the amplitude is 1, and if it is multiplied by some number, for example 10 times sine or 10 times cosine, its range becomes from -10 to 10, and the amplitude becomes 10 from the center, from the x-axis. Here it's called the principal axis to the maximum or to the minimum. If it is additionally there is additionally minus in front, it just means that this graph is reflected about the x-axis, but the amplitude remains the same. So the amplitude is just this coefficient in front of cosine or sine, without minus if it is present. And so the amplitude is 2 over pi. The period, x is measured in radians here, and period is 2 pi divided by this coefficient in front of x, divided by 3 pi, so it's 2/3. If x is measured in degrees, it becomes 360 divided by this coefficient in front of x. Or from the graph you can see for x is 2, there are 3 complete oscillations, and it means there are 3 periods. Hence one period is just 2 divided by 3. Question B, the point P has coordinates. State whether P lies above, below, or on the graph of f. Justify your answer. So let's consider the value of function when x is 1.63, so it's 2 over pi multiplied by sine of 3 pi times 1.63 plus 2. And what does it mean? It means what value of y must be a point to lie on the curve when x is 1.63, and then we'll compare with 2.16. So the value of a function of 1.63 is this 2.22 to 3 significant figures, and as 2.16, the y coordinate of a given point P is less than 2.22. It means what? That P lies below the graph of f. The next, the line L1 has equation given. Question C, write down the gradient of L1. We need to rewrite y is, because only when it is written as y is mx plus c, this coefficient in front of x, it's the gradient. Here it's not a gradient, so it becomes x plus 11 is 6y, hence y is x over 6 plus 11 over 6, y is, hence 1 over 6 is the gradient. So it's 1 over 6. The next, the line L1 is normal to the graph of f, at A with coordinates 1, 2. The line L2 is tangent to the graph of f at A. So this point, this line L1 is normal, so it's L1, and L2 it's tangent. And tangent is perpendicular to the normal. And we know if two lines are perpendicular, gradient of one is negative reciprocal of the other. Hence, the gradient of L2 is negative reciprocal. What does it mean? It's flipped and with opposite sign, so it's negative 6. So gradient of L2 is negative 6. And the equation of L2 as any line, it's mx plus c, and gradient is negative 6, so it becomes negative 6x plus c. And or you may use this form, y minus y1 is gradient x minus x1 with gradient is negative 6. And to find c, or to substitute for x1 and y1, you need any point on this line L2, and point known, it's where it is drawn, it's point A. So substituting 1 for x, 2 for y, we get that it becomes 2 is negative 6 times 1 plus c, so c is 8, hence the required equation of L2 becomes y is negative 6x plus 8. The next, the line L1 intersects the graph of f at another point B with x is greater than 1.5. Question E, find the coordinates of B. So just using a calculator. And first of all, there must be radian mode. And the first graph is our sine 2 over pi times sine over 3 pi x plus 2, and the second it's our line L1, it's x plus 11 over 6, then window x from 0 to 2 or 2.5, it doesn't matter, and y for example from 1 to 3, and graph it looks like this. And we need actually to be exactly like this, let x be 2 to be more clear. And you can see that B is here, this one, and then just calc, and we need intersection, point of intersection. So the first, the second, guess, and it's 1 point, and actually it will be required the exact, it's 164.85 and 6 and so on. So to 3 significant figures it becomes 1.65 and 2.11. And find the area of a shaded region. You can see that it's area between two curves, and we know that if there is some function f, it's another example, another function f, another function some g, and area between two curves can be found as a definite integral from a to b, the upper function minus the lower function dx. If you integrate g minus f, you get absolutely the same, but with minus. But here you can see that initially a line is above and then a curve is above, and if we integrate from a to b, just for example curve minus a line, it will be not correct. Here the absolute value is required, or another method to integrate separately from a to this point and then from this to this and add them by magnitudes, or here to get positive line minus a curve, and for this a curve minus a line. But to integrate from a to b, we need the absolute value, so it becomes definite integral from 1, because it's x coordinate of a, to x coordinate of b, which is this, as exact it's 1.64856 and so on, of the absolute value f of x, it's our sine, minus the equation of a line, or it may be the absolute value of equation, the equation of a line minus the equation of a curve f of x, it doesn't matter. So minus x plus 11 over 6, x plus 11 over 6. Oh, let's rewrite that it's what? It's 2 over pi. It's 2 over pi multiplied by sine of 3 pi x plus 2 minus x plus 11 over 6 dx. One 0.64856 and so on. It's absolute value. Absolute value is here mass, and so 2 over pi sine 3 pi x plus 2 minus x plus 11 over 6 dx. And we get that it's 0.253 to 3 significant figures. And again, it must be radian mode, and the absolute value it's here, this abs. And that's all for this question.